Here's some problems from 3.6. Let's start with problem number 1. In problem number 1, we are told that y is equal to sine of 3x plus 1. We're asked to find dy dx, and we want to think about the interior function as being 3x plus 1. So there are two ways to attack this problem. One is to think about y as being a function of u, and then dy dx ends up being dy du times du dx. Dy du ends up being cosine of u. Du dx is 3. And therefore we end up getting dy dx as being cosine of u multiplied by 3. And of course u is 3x plus 1 times 3, or we'll get our final answer of 3 cosine 3x plus 1. Now, also using the sort of inside-outside mantra, we say that dy dx is equal to the derivative of the outside function being sine, but we keep the inside the same, and then multiply by the derivative of the inside, and you see that we get the same value. Here's problem number 3. In problem number 3, y is equal to cosine of the square root of 3 times x, and only the 3 is under the root, and they would like us to find dy dx, assuming that u is equal to the square root of 3 times x. By the way, that means y ends up being the cosine of u, and again we can think of this as being derivative of y with respect to u times the derivative of u with respect to x. Dy dx, let's see, dy du here would end up being negative sine of u, and then du dx ends up being root 3, and so dy du negative sine of u times square root of 3, or negative square root of 3 times sine of u, but u is root 3 times x. Similarly, using the inside-outside mantra, we get the derivative of the outside, which is negative sine, keep the inside the same, multiply by the derivative of the inside, and you see that we get the same answer. Problem number 5. Y is equal to sine of x over 1 plus the cosine of x, and this is all quantity squared, and they would like you to think of u as being sine x over 1 plus cosine, and they would like y to be considered u squared. If that's the case, dy dx is equal to dy du times du dx. Dy du would be equal to 2u, and du dx ends up following the quotient rule, which is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's clean that up a little bit. I get cosine x plus cosine squared x plus, because of the two negative signs there, sine squared x, and that's all over 1 plus cosine x quantity squared, and then that ends up being cosine of x plus 1 all over 1 plus cosine quantity squared. Those two quantities are exactly the same, so I'm left with 1 over 1 plus cosine. So my end answer is 2u times 1 over 1 plus cosine. And of course, u is sine x over 1 plus cosine. And there's giving us a total of 2 sine over 1 plus cosine quantity squared. Now if I were to do the inside-outside model, you'd see we get the same answer, and because I want to avoid rederiving that mess, I'm going to skip that part. Typically I typically wouldn't use this definition of the chain rule, but let's just say for your demonstration and for your purposes, I think it's beneficial for you to see it this way right now. Okay, number 7 is y is equal to the cosine of the sine of x, and they would like u to be thought of as sine of x. That means y is going to end up being the cosine of u. And of course, if we want to find dy dx, we can think of it as dy du times du dx. Dy du is going to be minus sine of u, and then du dx is going to end up being cosine of x. So dy du, negative sine of u times cosine of x, and then we'll do our final substitution, negative sine of cosine of u times cosine x. Whoops! What u is equal to. Scratch that. That's supposed to be sine of x. In the other scenario, dy dx is equal to derivative of the outside, negative sine, keep the inside the same, multiply by the derivative of the inside, which is cosine x. So same answer, but it helps to see why we do what we do.